Investigate the graph of y equals absolute x plus or minus some constant. We're going to do this by hand, by table, with technology, and we'll generalize it. You will need graph paper or a page of grids, and this is part of the family of functions series. Here's the graph of y equals absolute value of x. It is in dashed blue. We're going to investigate with technology, and what we want you to do is to notice what is happening with the blue graph and the green graph, and also what is happening into the table as the value for v changes. So here we have the graph of y equals absolute value of x in blue, y equals the absolute value of x plus some constant in green. This is the table for blue values, table for green, and this is the slider that will change the value for the constant. So I'm going to increase v to 1. Like you look what happened to the graph and what happened in the table. We're going to look at y equals absolute value of x plus 2. See the graph compared to y equals absolute value of x and the table. Absolute value of x plus 3. Graph, table, absolute value of x plus 4. And 5. And then we'll go back down, and this time we're going to do absolute value of x plus a negative 1, which would be absolute value of x minus 1, graph, table. Y equals absolute value of x minus 2. Y equals absolute value of x minus 3, and so on. Press pause as needed. So based upon what you observed using the technology, create some conjectures, some thoughts about what happens to the graph of a function and to its table as the value of v increases and decreases in this equation. Press pause as needed. So using what you observe, graph the following by hand. So this is how we're going to graph y equals absolute value of x plus 3 by hand. And we're going to show you two different ways, and you pick which way you like, or if you have a better way, that's fine too. So the first way we're going to call the absolute value dance. We'll start with the vertex. It's normally at the origin, but because of the plus 3, we're going to have the vertex at 0, 3. And then from there we do the absolute value dance, which is to get that v. Right 1 up 1, right 2 up 2, right 3 up 3, and then left 1 up 1, left 2 up 2, and left 3 up 3 to make the v. And connecting the points, we get the beautiful absolute value graph. A second way is use a table, but we're not just by calculation. We're going to start off with y equals absolute value of x. And this would be our the standard values here. We'll do these 5 points here. So now when we do the absolute value of x plus 3, we know that the plus 3 adds 3 to each y coordinate. We just observed that. And so the corresponding value, this 2 will go up to 5, this 1 goes up to 4, this 0 goes up to 3, and again 1 to 4 and 2 to 5. So we now have 5 quick points with very little calculation. And so we're going to go ahead and plot those points. So 2, 5, 1, 4, and so on. And those 5 points do trace out the v, so we can go ahead and connect them and make the absolute value of x plus 3. Let's try one other example real quickly. The absolute value, y equals absolute value of x minus 4. Again, the absolute value dance, we'll start with that one. And just as we did before, we'll start with the vertex, which is normally at the origin, but because of that minus 4, it's going to be at 0, negative 4. And from there, we will do our absolute value dance. Right 1 up 1, right 2 up 2, right 3 up 3. And we could also use symmetry, but we'll just go left 1 up 1, left 2 up 2, left 3 up 3. Connect the points, and there's our absolute value of x minus 4. If you'd like to do it by table, again, we start off with the traditional absolute value of x table, and each y value is going to be subtracted 4. So the 2 will go to negative 2, The 1 will be -3 and the 0, -4. 1 will again go to -3 and 2 to -2. And we have 5 points. We can go ahead and plot. 2, -2, 1, -3, 0, -4, and so on. And there's our absolute value v that we can connect the points. So the summary for this, for absolute value of x, y equals absolute value of x plus some constant v. If v is positive, then the whole graph of y equals absolute value of x is shifted up v units, in this case 3. You can also see it in the table, shifted up 3. And if v is negative, the graph of y equals absolute value of x is shifted down the absolute value of that number units. So in this case, if it's -6, this is shifted down 6 units here.